Hello and welcome to this news briefing from the 249th National Meeting and Exposition of the American Chemical Society in Denver. We're joined today by Dr. Olia Keene from the University of North Carolina at Charlotte, who has discovered how wastewater treatment might be contributing to the growing problem of antibiotic resistance. Dr. Keene.
Hello, everyone. Yes, as you know, there are pharmaceuticals in the environment, so that is not news. And there also have been studies that confirm that antibiotics in wastewater lead to development of antibiotic resistance in the environment. And what our research showed is that during disinfection of wastewater with chlorine, which is one of the most common disinfection methods, chlorine reacts with some of these pharmaceuticals and forms other compounds. We have worked with just one antibiotic so far, but we have seen that the products that form in the reaction between this antibiotic, doxycycline, and chlorine form other antibiotics, and that's what we've been able to show through exposing microorganisms to the chlorinated doxycycline samples.
Okay, thank you. And do we have any questions from the audience? And please state your name and affiliation before asking a question.
So it's Kath O'Driscoll, and it's from Chemistry and Industry magazine. I understand that some of the antibiotics that you found that have been made as a result of, I guess it's chlorine oxidation of these pharmaceuticals, are actually more potent than the original antibiotic. How much more potent? And could this be a valuable source of, new source of to discover antibiotics, because we're desperately in need of them?
Right. That's a good question. We found that it's probably, it's difficult to quantify right now at our stage of research exactly how many times more potent. We would have to isolate each of these products that form and test each of them separately. It might be very challenging because we would need to have some kind of standards to test them against to figure out what concentration they're in. That could be one of the topics for continued study, but as I mentioned, that is pretty challenging. So what we're trying to do right now is identify some of the structures of the products that form, and then maybe they could be synthesized separately and tested. One of the antibiotics, one of the products that we identified is similar to chlortetracycline, but it's not exactly the same. So chlortetracycline is an existing antibiotic. However, one of the concerns, I do think that there is room there to see which of these products might be our next antibiotics. That's definitely would be an interesting spin-off of this study, even though it started from the perspective of just looking at the environmental effects. But chlorinated organics a lot of times have properties that are not very desirable in chemicals that we might ingest. So, for example, chlortetracycline is rarely used on humans. It's more of a veterinary antibiotic because of the side effects that it has. So this other antibiotic that we showed that forms is very similar to chlortetracycline, and it might have the same side effects as chlortetracycline. But again, that's something that's definitely worthy of investigation.
Are there particular pharmaceuticals, sort of structures, that are most vulnerable to this type of chlorine attack, or that conversely that are able to resist chlorine degradation?
Most of them would be susceptible to chlorine attack. Chlorine reacts very readily with double carbon-carbon bonds on organic molecules. And most of the pharmaceuticals will have some location on them that would be susceptible to chlorine attack.
Thank you. Mm-hmm.
Do we have any other questions?
Bela Buslik, ACS News Service. Is the form of chlorine used in wastewater treatment going to make any kind of difference in what you're, well, obviously it should make some difference, but is there a form of chlorine that perhaps not as deleterious, like chlorine dioxide is one of the things that is being used, which doesn't exactly chlorinate things, it just destroys the hex out of them, so.
Right, right. So chlorine dioxide will go through different reactions compared to free chlorine. I believe there has been some research done with chlorine dioxide that shows that it's less likely to form chlorinated compounds or, than free chlorine. So that could be one of the alternatives for disinfection if we don't want to form these chlorinated compounds. Yes, so.
The other question is since the abstract essentially refers to doxycycline, how much of a potency increase do you get if you chlorinate the compound?
Right, right. So that's something that's difficult to quantify at this stage. It would require much more experimentation to figure out the actual numeric increase in potency. Is that doxycycline, the parent molecule doxycycline goes away after chlorination, but the potency of the sample against microorganisms goes up by about a factor of 6. But again, this potency that we see comes from a mixture of different products that form. So we cannot attribute it to any of the specific products right now.
So potentially, you've got a situation where you might be able to create a chlorinated compound that perhaps is much more effective at lower dosages.
Right, right, yes. Yes, that is definitely a possibility.
Thank you.
Okay, thank you. And we do have a question on the internet.
Okay, so we have a question from ACS News Service. At what concentrations are these antibiotics occurring, and what levels should we be concerned about?
They are occurring usually in nanogram per liter and low microgram per liter concentrations. And as far as an acute health effect for humans, this is not considered a concentration of concern, but there have been studies that showed that at these concentrations, these antibiotics actually cause development of antibacterial resistance. And that's particularly because these concentrations are subinhibitory. So these microorganisms, they just get accustomed to these molecules, they get selected for resistance. So low concentration is definitely not the reason not to be concerned.
And also, I have a question. I'm Katie Cottingham, ACS News Service. So I was wondering, how did you get the idea to look at whether new antibiotics were being formed in sewage treatment water? You know, how did you even get an inkling that this was going on?
Right. Well, my research so far has focused on different treatment processes, chemical treatment processes for wastewater, with the goal to transform these pharmaceuticals to the point where they're not harmful to the environment. And in one of my studies with a different treatment process, I saw that there are some intermediate antibiotics that form during the process that I was studying. That was UV hydrogen peroxide advanced oxidation. And from there, I thought to look into chlorine because chlorine is known to react with organic matter across the board. And one of the prominent reaction pathways is for chlorine incorporation into the organic structure, which a lot of times leads to properties of concern in organic chemicals. So that's why I thought that there was a good chance that whatever forms would have some kind of antibacterial activity. So I anticipated in the sense that that would be the result.
Okay, do we have any other questions?
So just to ask about the regulations surrounding disposal of pharmaceuticals. I guess there aren't any at the moment, but are there efforts to actually regulate the disposal of pharmaceuticals?
So far, I think there's just an effort to educate the public Regulation is always very difficult to come by because then you have to think about how to enforce this regulation. And because it's something that is just in people's households, it would be very difficult to enforce any kind of regulation with that respect. So I think public education campaign is probably the first step to do. The best disposal method would be to collect these pharmaceuticals at pharmacies, at drop-off locations where they can go into incineration.
Are there any particular pharmaceuticals that are more concerned than others? What are the top ones of causing a problem?
Right. Well, antibiotics definitely, because of the link with antibacterial resistance, and this is such a huge health problem that we're facing right now. Another big group of pharmaceuticals that are of concern are endocrine disrupting compounds. So those are either hormone or hormone mimicking compounds, which are not necessarily always synthetic hormones. This could be things from household products, plasticizers, detergent components. So those are also of huge concern to ecosystems because they have been shown to cause feminization of fish and reptiles. There have been some other studies that shown that psychoactive compounds might be an issue to the environment because they can change the reaction mechanisms to predators, and that could upset the food chain. So these are some of the compounds of the most concern as
Thank
far as
you.
we know right now. Yeah.
Okay, and I think that'll be all. Thank you. Thank you, Dr. Keen. And
Thank you.
the archived version of this session will be posted at bit.ly/ACS Live Denver. Please join us for our next press conference today at 11 a.m. on turning packing peanuts into battery parts. Thank you.